Electricity has an important place in modern society. It is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries, and so on. Actually, what constitutes electricity? How does it flow in an electric circuit? What are the factors that control or regulate the current through an electric circuit? In this chapter, we shall attempt to answer such questions. We cover some of the important concepts related to the electric current. We are familiar with air current and water current. We know that flowing water constitutes water current in reverse. Similarly, if the electric charge flows through a conductor, for example, through a metal wire, we say that there is an electric current in the conductor. In this chapter, we cover certain topics related to the electric current. These are current, Ohm's law, resistance, simple circuits, resistance and resistivity, electric power and energy. These concepts are covered in this module. Okay, the first concept is current. What are the learning objectives of this topic? Students are able to define electric current, ampere and drift velocity. They describe the direction of charge flow in conventional current. They use drift velocity to calculate current and vice versa. Drude and Lorentz, these are the scientists of the 19th century, proposed the conductors like metals contain a large number of free electrons, while the positive ions are fixed in their locations. The arrangement of the positive ions is called lattice. In this diagram, the red spots, the positive ions are fixed in their locations. And we also observe that some of black dots are randomly distributing. These dots are nothing but negatively charged electrons. The electrons are responsible for this transfer of electrical energy. If the electrons are responsible for the transfer of electrical energy from battery to electrical device, they must have an ordered motion. Look at this figure carefully. When the ends of the conductor are connected to the battery through a bulb, the bulb glows because energy transfer takes place from the battery to the bulb. As said earlier, the electrons are responsible for this transfer of energy. We can say that the electric current is ordered motion of charges. Now, let us define electric current quantitatively. How do we express electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of electric charges. In circuits using metallic wires, electrons constitute the flow of charges. However, electrons were not known at the time when the phenomena of electricity was first observed. If a net charge Q flows a cross section of a conductor in time t, then the current I through the cross section is I is equal to Q by T. This is the formula for the current, where delta Q is the amount of charge passing through a given area in time delta T. Okay, the SI unit for current is the ampere. This unit is named for the French physicist Ampere. Since I is equal to delta T by delta T, we see that an ampere is 1 coulomb per second. From the above topic, we can define electric current as electric current is defined as the amount of charge crossing any cross section of the conductor in 1 second. It is denoted with the letter I. Its SI unit is ampere. It can be mathematically written as I is equal to Q by T. The terms related to the formula are Q, amount of charge, and T taken as time. As mentioned earlier, the electric current is ordered motion of charges. Why do electrons move in specified direction? Let us see what happens here. When the conductor is not connected to the circuit to throw a battery, the electrons inside the conductor are in random motion. But when the conductor is connected to a battery, the electrons move in a specified direction. This shows that something causes the electron to move it in a specified direction. When the ends of the conductor are connected to the terminals of a battery, a uniform electric field is set up throughout the conductor. This field makes the electrons move in a specified direction. How we can define ampere? If 1 coulomb of charge crosses any cross section of the conductor in 1 second, then the electric current flown through that conductor is 1 ampere. So it is denoted with the letter A. Mathematically, 1 ampere is equal to the 1 coulomb by second. And this diagram shows about the direction of electron motion in an electric circuit. Observe this diagram again carefully. The uniform electric field makes the electrons move in a specified direction. Now some questions arise by this topic. What are they? In which direction do the electrons move? Do the electrons accelerate continuously? Do they move with a constant speed? These questions should be answered.